Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing Layer 2 switching and VLANs, where we're covering Layer 2 switching mechanisms and Ethernet switching configurations in Junos. In this lesson, we'll be covering VLAN tagging in a bit more detail. Additionally, we'll review how to configure a trunk port in Junos, as well as a voice VLAN. Voice over IP, or VoIP, is commonplace now, allowing for office buildings to consolidate physical infrastructure, since the phones and computers can use the same physical cabling and wiring infrastructure, instead of having separate phone and data wiring. Voice traffic, however, is often considered a much higher priority than most other data traffic. This is primarily because of the tolerance, or lack thereof, of latency and packet loss when it comes to voice traffic. Because of the real-time nature of phone calls, if a packet is delayed or out of order, this very quickly results in a very negative user experience during the call. General computer data traffic, however, is typically quite tolerant of latency and loss. Layer 4 and higher protocols, like TCP, have mechanisms built in which allow for the detection of packet loss and retransmission of data in the event of packet loss. This is usually acceptable because the data isn't needed in real time. If the data is delayed a half second, the protocols can handle it, and it's okay. Because of the differences here in how voice and data traffic can be handled, voice traffic is generally differentiated from data traffic to allow for different handling, and this differentiation is often done initially with a voice VLAN. So let's review very briefly VLAN tagging. VLAN tagging is done using a frame header field, which is defined in 802.1q. Every transmitted frame across a tagged link will have this header field set to the VLAN ID the frame is a member of. Recall, though, that ports may be configured as trunk ports or access ports. Where access ports carry untagged traffic and are members of a single VLAN, trunk ports carry traffic for multiple VLANs and differentiate the traffic using VLAN tagging. In the next slide, we'll take a look at how to configure an interface as a trunk and associate multiple VLANs with it. We see in this configuration snippet that these two interfaces are configured as interface mode trunk, allowing them to carry tagged traffic and be members of multiple VLANs. In the VLAN members configuration, multiple VLAN selections may be made, or the trunk may simply be configured as a member of all configured VLANs. Now that we know how to configure a trunk port, let's take a closer look at the voice VLAN. Many voice over IP phones will have two RJ45 ports. One port is meant to be connected to the network switch, and the other connected to the workstation. Although voice VLAN configurations differ between deployments and vendors, often the phone will tag its traffic with the configured voice VLAN, and the user data traffic will be untagged. As we see in the diagram here, the tagged traffic is sent and received by the phone, whereas the untagged data VLAN traffic intended for the workstation is passed through the phone and sent to and received by the workstation. Now, let's see how we can configure this on the switches side of things. The voice VLAN is configured in the Switch Options VoIP section of the configuration hierarchy. This configuration allows for the transmittal and receipt of tagged traffic on an access port. As we mentioned in a previous lesson, these ports are indeed still considered access ports, even though they send and receive tagged traffic, since they are doing so as a member of a voice VLAN. When configuring the voice VLAN, we have the option of specifying individual interfaces which should participate in voice VLAN, or simply configure to have all interfaces configured in the interface mode access to participate in the voice VLAN. The VLAN ID that the voice VLAN is configured for may be specified using either the VLAN ID or the name of the configured VLAN in the VLAN section of the configuration hierarchy. Although it's not covered in the JNCIS ENT, I did want to mention that it's possible for the VoIP phones to dynamically learn what VLAN ID to tag voice traffic with by LLDP MED. A TLV within the LLDP MED protocol can be added to the LLDP frames sent by the switch, so the phone may learn what VLAN ID to tag its voice traffic with and what VLAN ID to expect on return traffic. Type length value fields and the details of LLDP, though, are outside the scope of this particular lesson. Finally, let's take a look at how an interface configured to participate in voice VLAN shows in operational mode commands. As we see here, interface GE000 is configured as an access port using the interface mode access command. Additionally, down here, we see that GE000 is configured specifically to participate in voice VLAN, with the VLAN named voice designated as the voice VLAN. When we review the output of show VLANs, we see that the interface is indeed showing as a member of multiple VLANs, even though it is configured as an access port. I appreciate you working through this lesson with me on voice VLANs and trunking and their configurations. I hope that this has been informative for you, and I would like to thank you for viewing.